Good day, we are the Real Estate Data Analytics Group. Housing is a right that every person deserves. In this video presentation, we will explain our data analytics lifecycle that aims to understand the real estate house prices.
Hello, this is our final project for IT030 Data Analytics, presented by Bautista Danwer Bral and me, MISA Joel Brick, Perdido Matthew Emil, SIGNO Julian Carlo. Hi, my name is Jericho GESMUNDO. This is the phase 1. Understand the business problem. The study will analyze and understand the demand in real estate housing bubble as well as affordability of housing. The model will tell if the minimum wage earners can also afford it as well. And these are the problems. Now for the objectives, evaluate affordability of housing in America in consideration towards the minimum wage earners' salary and to find out if it is affordable for the middle to lower classes. Utilize algorithms, pre-processing methods, and modeling techniques to analyze the datasets. To do those, we require data sources, the RStudio application, and Google Sheets or Microsoft Excel. Now for the data analytics problem. The demand for affordable housing is constantly increasing, and as the market increases, the prices for affordable housing also goes higher. The salary of minimum wage earners does not grow at the same rate as affordable housing has a glass ceiling in terms of its pricing. Developers cannot produce the supply of affordable housing at a fast rate, and regulators can say that its supply is constant. This overpricing of affordable housing may lead to market bubbles. Market bubbles are a concern for housing as shelter is a human right that serves as a primary need for individuals. This bubble is problematic not only for minimum wage earners but also for investors because bubbles tend to push prices to unrealistic values. If shareholders with the most shares sees this as an opportunity to sell their shares, this can drive down the costs and result in a loss for other shareholders. And now, these are the data analytics questions that will support the problem statement. Will the housing market experience a bubble? Is the housing market experiencing a boom or inflation? What are the factors that affect the price of a house? Does the age of a house affect its general price? Are price irregularities a sign of an inflated real estate market? Now for the phase 2, data collection and integration. For the phase 2, we merge several sources into one dataset. The goal is consistent access and distribution of data in various topics and structure types. The researchers set up the criteria where datasets must contain the columns type, type of house unit, BR for bedroom, H for house, cottage, villa, semi, terrace, U for unit, duplex, T for townhouse, dev site for development site, O for res, and others. Price, total price of the house. Distance of the house from the nearest commercial district. Bedroom, total number of bedrooms in the house. Bathroom, total number of bathrooms in the house. Car slots that fit in the garage. Land size, total area units. Year built, the year when the house was completely built. Now, these are the 3 datasets that were taken from www.kaggle.com. Define the process of data collection. In defining the process of data collection, at the start of the project, we decide on commercial or research problem that will be solved. Then, we will obtain the necessary data to provide information or data or that responds to the business query. The third step is to determine the datasets that deliver the required information. Fourth, establish a strategy to gather data. and as well as the techniques employed. And finally, start collecting the accessible data and work on getting it ready for analysis. Now this is a CSV data reading where we import the data from a text file, web scraping, and here is the integrated dataset.
So my name is Julian Carlos Signo, and I'll be explaining the phase 3, which is pre-processing the data. So the characteristics of data include inconsistencies, noisy, and incomplete data. So by completing missing or partial data, this will improve the overall quality of our dataset. So these are the following data pre-processing technique that will be used to our project. So first is data cleaning methods. Since the majority of data is noisy, as a result, the binding method will be applied to treat or smooth down noisy data. So the figure below, this is an Excel data feature that cleans duplicates of a certain column. So next is normalization method. So the z-score normalization method will be used for the pre-processing of the dataset. So the z-score will help in determining how much a data deviates from the mean by calculating the standard deviation above and below the mean. So next is fix missing values in the data. So the missing values will be fixed by replacing it with the mean or median after sorting the data. So this is a feature of RStudio, which is any mini functionality that replaces missing values with a mean or median. So next, so this is also a feature of Excel, which is filtering blank rows through Excel data processing. So next is pre-processing that deals with missing values. So in here, this is a coding structure in RStudio. So and below that is pre-processing in categorical data. So in our data set, we have categorical attribute, which is the house type. So sometimes the system doesn't accept non-numeric values. Therefore, we need to convert it to numerical. And in R, so we can use the factor method to convert text into numerical codes. So lastly is pre-processing, which is splitting data into sections. So we require data that has never been seen by the model previously in order to assess model performance. So additionally, we may determine whether a model is overfitting or underfitting the data by utilizing a data set.
For phase 4, explore and visualize the data. So the following graphs and statistics of the integrated dataset are the attributes that are being evaluated to determine its relevance to one another and how it will affect the affordability of the houses, and thus these attributes push the price to market bubble prices. So for this image, understanding this summary of the listed columns give us the mean, median, minimum value, and maximum value, which we can use to interpret the dataset values. For the next slide, we have mean median. So the mean values of the attributes. The real estate summary provides us that in the western campus of the world, the mean price of houses stand at around $1,665,797. The average distance of house from the nearest commercial center is around 9.3 kilometers. For each household, there is an average of 3 bedrooms and 1.575 bathrooms or 1.6. There are an average 2 cars, that's each garage or parking space, and most of the recent sold houses were built in the year of 1970. So for the median value of the summary helps us to estimate the median house value of the dataset without being affected by the outliers or values that are proportional outside of the range boundary. Comparing the mean and median for the house prices gives us a much larger value of $1,065,797, which is a $185,797 difference from the mean. The distance as a median of 9.3 feet has a difference of 0.81 km upon comparing it to the mean. Bedrooms have a median value of 3.0, which is slightly higher than the mean, giving us a negative 0.089 difference. The attribute bathroom has a median of 1.0 and a mean of 1.575. a difference of 0.575. So the car attribute is a median of 2.0, which is 2 slots for cars and mean of 1.590. Comparing it, the difference of negative 0.409, meaning it is negative is few. The middle value of the last size attribute is 388. The difference is 106. The year built attribute median is 1970. So for the next slide, we have the range. The range depicts the endpoints between minimum and the maximum, which provides an overall dispersion of the dataset. The minimum for the price is $85,000, while the maximum is $9 million. In the attributes, distance is a minimum of 0 km, while it has maximum 47.4 km. The minimum for the bedroom is 0 bedrooms and has a maximum value of 10. Bathrooms have a minimum of 0 and maximum value of 8. Car has a minimum of 0 and maximum of 10. Land size has a minimum of 0 and maximum of 37,000. The year built has a minimum of 1196 and a maximum of 228. Next slide is the mode. So the mode is the most frequent value that appears inside the text. For the type of unit, it is H, which stands for house, and for the price is $600,000. We also found out that the distance to the nearest commercial district is 11.2 km. The mode of bedrooms, or how many bedrooms there are in the house, is 3, and the bottom is 1. It has mode of 1 for the car attribute, meaning there is only one stand per vehicle, while the land area has mode of 0. Lastly, the most common year when the buildings were built was 1970. For the next slide, quantiles. Quantiles in R is referred to as the percentile of the attribute figures. In the case price, quantiles is the most important attribute to be discussed. So here we found out that the cheapest houses sit around at $85,000. The average houses prices at 25%, 50%, which is $650,000 to $980,000. And the uppermost expensive houses market is 75% and 100%, sits at a $1,330,000 to $9 million. For the next slide, we have the plot. So for the plot, we have used data with a reduced number of rows to show the proper plotting of the prices. The plot shows us in this case how the price for the houses move in the direction of its amount. The plotting helps visualize how the prices for the real estate vary depending on what the factors of which its price set. For the next slide, we have histogram. The histogram shows us the frequency distribution of the real estate prices. Deriving conclusions from the results gives the impression that the majority of the house prices are in the lower distribution area. This graph gives us a right skew distribution. For the next slide, we have box plot. With the box plot, I compare the attributes with the nearest value to each other, which in the case of real estate is the number of bedrooms, number of bathrooms, and the total cars that available in the garage. The box plot in this dataset shows us the indication of how our selected attributes are spread. For the next slide, we have scatter plot. It shows the unit price sold relative to the distance of the unit from a commercial district. The result of the scatter plot shows a chaotic relationship between the graphs, meaning the distance of the house unit from a commercial district does not affect its average selling price. And for the probability distribution of attributes, it shows all the possible values of 10 groups a random variable can take within a given range. For the color red is the bathroom, color blue for the bedroom, color green for the garage, yellow for the prices, and the black is the normal or the average. Next slide, I will pass it now to the next presenter.
So I am Perdido MLV, and I will be discussing about the phase 5 and 6 of our presentation. Phase 5 is where we will determine the algorithm that we will be using for our project, and these algorithms will be tested and performed in RStudio. First is the naive-based algorithm. This algorithm sorts the data depending on the attributes that this data possesses, and the result shows that only 3 house types are relevant, which are the type H or house, the type T or townhouse, and the type U or unit. 66% of the dataset consists of type H, 9% of the dataset consists of type T, and the remaining 25% consist of the type Q. So next is the confusion matrix. We use the confusion matrix for the accuracy of the sorted data, and the results have shown us that there are 1734 for the type H, 192 for type T, and 571 for type Q. These are all true positives, or which are the accurate data of the dataset. So next is the nearest neighbor, and this is our results. And lastly, we use the random forest. So the random forest is where we trained a dataset with a split of 70-30, and it yielded a value of 86%. The accuracy of the random forest model to predict the price, distance, bedroom, bathroom, car, land size, and year built is around 86%, which is a very high percentage, and it is a good yield of results. So next is the phase 6, where we will be evaluating all the graphs that we have created. So for phase 6, we will be showing this, the first one, the cluster graph, and here it is visible that on the cluster graph, the blue cluster has the largest amount of data and has the and this means that it has the most similar features to one another. Next is the decision tree. We use this for sorting the data into different hierarchy, and that for the different hierarchy that we have created. This hierarchy are the affordable, the median, the upper median, and the luxury. So for analyzing this decision tree, let's go back, and houses that have less than or equal to 3 bedrooms have been classified under the median class. And below, those houses who have 1 to 2 bathrooms and less than or equal to 2 bedrooms are classified under the affordable class. On the other side of the decision tree, which are houses that have 3 or more bedrooms, only a few made it past the median class. So let's see. So this is the other side, and it is true that only a few have made it past the median class, which makes them the upper class. And lastly, only a few houses are classified on the luxury class, and the plot shows that there are only 3 dots on the plot that are classified as the luxury class. And as you can see here on the graph, it is true that 2 of those dots are on here on the expensive side, and 1 seems to be on the less affordable side. So next is the linear regression, and as you can see from our graph, it is true the data is scattered, but it is true that as the land size gets bigger, the price also gets higher. So as you can see here, it is also true for the multilinear regression. The multilinear regression shows us that as the land size grow here on the x-axis, the price goes up, which is the y-axis. So that is all for phase 6, and I will now be passing this to the next presenter.
Hello, my name is Don and Bautista, and I will be reporting the report to management and review. So this is the phase 7 of our data analytics lifecycle. So we are first starting here with our target organization. So we have here the Home Shelter Realty Corporation. So this one is based on Marikina, and it focuses on selling houses at affordable prices based on mean income per capita. So they try to calculate the average salary of a middle income family, and they provide homes to those people. Next one is the Home. So this one is a housing developer that specializes in constructing and building affordable housing with low interest and down payment. And lastly, we have the Home Development Corporation, or the HDC. So it is a housing developer with emphasis on sustainability and livability on real estate properties. So we would chose to target this organizations because they are aligned to the benefits that we want to provide with the study that we have done here in data analytics and review of our modeling. So we can now proceed to the average house pricing. So the excuse me, the average house pricing in the different suburban neighborhoods give us a range of $850,000 to $900,000, which meets the international standards of affordable housing. So with these results, with the analysis we performed, so we know that the market is not in a bubble and the prices are not significantly inflated. So they are at the regular inflation. Uh, what can we derive from this? So we can derive from this that from our study, there is no bubble looming it at the real estate housing market in the different areas of we have collected from. So we are talking about in Melbourne, in the state of California in the United States, and also in New York, which is also in the United States. Next is the real estate price percentile. So at the 100 percentile, you can see here that the median average of a house can go to $9 million. So of course this is not the representation of the reality, because this one is a luxury real estate, and we all know that luxury real estate can go to exorbitant amount of selling prices. Because they target those top 1%, those millionaires, multimillionaires, and billionaires. So it is wrong to assume that this is an example of an inflating house unit. Excuse me, because real estate outliers in a dataset, so they are mostly anomalous when it comes to dataset. So we still decided to include these values because we want it to be as realistically as possible. So even though they are not representing the actual reality, it is still good to use this outlier data to have a proper assessment on the situation in the luxury real estate. Next one is the statistical graph from the Organization for Economic Cooperation and Development, so the OECD. So it shows here that the real estate market data presents that real life trends in terms of average price in real estate. So the study that we have performed, it matches with the global market. So the global market is experiencing a rise in real estate prices, but not at a very high rate. So the excuse me. So this brings us to the conclusion that the global real estate index is at a fairly low inflation rate compared to other markets such as the commodities. So our future models presentation, we first have the forecast model. So if we will be presenting to more organization and they ask us for further evaluation of modelings, so we have here the forecast model. So this one is perfect for understanding future market housing bubbles. So descriptive model if the analysis of the forecast model to understand whether a particular area is experiencing something such as the housing boom. A time series model to understand the average increase of houses sold in a time span of year. And forecast, so this one is analysis of patterns and correlate how housing market rise, price, or fall based on attributes or different factors. And last one is descriptive model. So the descriptive model, we need to understand here the speculative nature of real estate investment. And we're now at the last slide. Excuse me. So at the last slide, we have the after deploying the model. So this will decide if the research that was done is successful in becoming a solution. The deployment of the model seeks to feed the model with information from real estate prices of the house. So distances to the nearest commercial district, bedroom, number of bathroom, cash lot, to the size of land, to the year of houses predicted. So at the deployment of model, we are expecting here to provide the different techniques that we have used to be applied to other data sets, so that our study can be used at a universal level. They have a proper assessment of how things go in the real estate, and we are aiming for that in the deployment of the model.